Hello students, welcome back to supplementary video lecture series of design of connection. Based on the request from the various number of students, I have prepared there is another one video along with the design of bolted connection. In this video we will see the practice example of the design of welded connection. So earlier in the lectures we have seen the different type of the welded connection for the plates. Either it is a fillet weld or it is a groove weld. Here we will see specifically the same data which we have used in the previous video for the bolted connection. So you may imagine the similar type of the connection that there is a one angle section and which is connected to the gusset plate, and in place of the bolt we have to design for the welding over here. So the data is the same. The member of the steel roof truss that is a consists of the single angle ISA 100 by 75 by 8 mm, which is a connected to the 8 mm thick gusset plate. Member carries the ultimate tensile load of the 150 kilonewton and design the welded connection if longer leg is connected to the gusset plate using the fillet weld. Assume steel grade 410. Here, as it is a bolt is not required, so ultimate strength of the plate is a 410, and approximately the yield strength of the plate is a 60% of the ultimate, so it is a 250 Newton per mm square. So let me start with some basic data for this particular practice example. So here, whenever we have a weld, so we have to decide the couple of things, which is a size of weld, throat thickness and length of the weld, which is a part of the design of welded connection. So first, if we have to decide the size of the weld, so in the page number 78, in the table number 21, it is a mention that if the size of the weld is a depend on the thickness of the plate. So if the thickness of the plate is ranging from the 0 to 10 mm, then minimum size of the weld we have to take in as a 3 mm. So that you can refer it from the table number 21 first row. Then what is the maximum size of the weld? That is approximately we can take as a T minus 1.5, which is given the same page number 79. So it is a T is a 8 mm thickness and minus 1.5, that is a become a 6.5. So this is a range of the size of weld, that minimum size is a 3, maximum size is a 6.5. In between you can take any value, whatever you want to assume. So right now we are assuming 5 mm size of the weld, so S will be 5 mm. Next, there is a throat thickness. So what is the effective throat thickness? That is a given on the page number 78, the clause number 10.5.3.1, that is a 0.7 times size of the weld. So size of weld is a 5, so throat thickness is a 3.5 mm. Next, there is a design strength of the fillet weld. So design strength of the fillet weld is a FWD, that is equal to FU divided by root 3 gamma MW, which is almost similar like we have considered in the bolted connection, that here there is no role of the NN A and B because there is thread strength of the bolt is not required, so remaining part is the same. Only the difference is that we have to consider the partial safety factor for the weld in place of the bolt. So that is a given on the page number 79. Ultimate strength of the plate, that is a 410, while gamma mw, that we have a variation depend on the type of the weld. That suppose if you are either doing the shop weld or field weld, so why we have to change? Because in the bolt it is not going to affect, but where we are going to do the welding, so the temperature and environmental factor for the shop and field, that will be different. So suppose right now if you are go back to the data, and you can see that it is not mentioned. So whenever it's not mentioned that where this specific application of the joint will be there, so you can assume it by your end. So we will assuming right now as a field weld. It is up to you. Suppose if you are doing that specific connection in the shop, so you can assume as a shop weld also, and accordingly the factor of the partially safety factor will be going to change from the page number 30, table number 5. So right now we are considering this a 1.5 as we are assuming the field weld. Whenever you are assuming something, you have to mention your assumption along with this. So FWD will be become a 158 Newton per mm square. Next, this is a tentative type of the connection where here what happened that when we have discussed about the plate, so as it is a rectangular plate, so CG will be at the center only. So on the when we have to weld on the sides, so on the top and bottom or toe and heel both the side it will be the similar length we have to do, because of the CG will be at the center. But in the angle section what happened that CG will be not at a center. So if we are going to provide the weld, so length of the weld will be more in the bottom side. So this is a, we are providing the 5 mm size fillet weld, and we have to design the length of the weld LW1 and LW2. So here we will consider that P1 if the force is extracted by the length of the weld LW1, and P2 that is a force which is resisted by the weld at the bottom or heel side. So that is a P1 and P2 individual forces, and LW1 and LW2 that is a length of the weld we have to consider on the both the side. There is an additional thing CZZ or CXX you can consider, there is a CG from the bottom axis, so that you can find out from the steel table. So if you go to the steel table in the unequal angle section, you may find out the CXX or CZZ value, which is given in a 3.1 centimeter, that is nothing but it's a 31 mm. So basically this is our partial detailing, and based on that we have to find out these two forces. So what we have to do that here we have to consider this point, this blue mark point is shown. So from the bottom edge we have to take a moment of the forces. So what we can see on the top, that is a force P1 multiplied by 100, that is the total distance over here, while there is a 150 that is going to acting at the CG, so that is going to multiply with a 31. So the force P1 will be 46.5, and total force is a 150, so P1 plus P2 is a 150, so we have to deduct the 46.5, so P2 will be 103.5. Now we have individual forces, so we have to find out the individual length of the weld. So we have an equation for the force, that is a P1 equal to LW1 TT FWD. Similarly, P2 equal to LW2 TT FWD. This equation you can find out from the page number 80. So on the page number 80 below the figure you can see this equation. So we have to put the value of the P1 TT FWD. So from that we will get the LW1. Along with this you can see there is a end return, that whenever we have to provide the side weld, so additional few length we have to provide on the after the corner. So there is a end return is nothing but 2s, size of the weld is a 5, so end return is a 10 mm. So total distance, total length of the weld is a 94.08, that we can round up to the 100 mm. Similarly, for the P2, there is a LW2 TT FWD. So P2 value will be going to differ, and based on that, LW2 is a 187.16. Similar to that, we have to add the end return. So it is a 197.16, and we can round up to the 200 mm. Last but not least, here we have designed the size of weld, length of the weld, and we have to design the throat thickness. So here our design is completed. You can try to refer the standard reference book and try to solve some more example what is going to change with the varieties of the connection, that you may refer it. Before ending this, so this is a review question for this session, that if the similar like in the case of the bolted connection, if in the weld also if we are using the 2 ISA on the back to back and longer leg is connected with a gusset plate, so what will be the change in the design point of view? So with this we are concluding this video. Thank you, and you have to just do the more practice with some standard reference book and give the answer of this review question in the comment. Thank you so much.